Hello, welcome back to the channel. In this video, I am going to discuss Cambridge International AS Physics Paper 2, October-November 2024, Paper 21. Right, let us get started. Now, let us look at the first question. First question, define density. Don't you think this question is very similar to IGCSE physics? Right, how 1 mark is given for the definition of density. So density is being defined as mass per volume. That's it. Done. B, Fig 1.1 shows a cuboidal glass block. A student measures the mass m of the block and the side length X, Y, and Z. The measurements are shown in table 1.1. Now, determine the density of the glass, and they gave you 2 marks. First of all, since we have already defined density, just write down the equation of density here. Density is equal to mass over volume. Since this is cuboid, right? How do you find the volume of the cuboid? Volume is equal to X times Y times Z. That's it. Right, now I'm going to do that. Mass is given as 0.243 kilogram. So I'm going to put that 0.243. I just copy. Divided by volume. Okay, I want you to see this very, very carefully. Right, look at the unit of density. The unit of density is in meter per meter cube. The volume must be in meter cube. So I have no choice but to change the x to meter. Just don't bother about the absolute uncertainty first. Right, change the x from cm to meter. So 5.41 from cm, 5.41 cm, you want to change it to meter, you just divide by 100. So here, I'm just going to write that here. This is 0.10541 meter. And y, you divide 100, you get 0.1109 meter. And z, you get 0.0162 meter. Right, once I got all this value, I have already converted to meter. I'm going to sub into the equation of volume, which is 0.0541 multiplies by 0.1109 multiplies by 0.0162 meter cube. Right, now let your calculator handle the rest. Right, so you will get 2,500 kilogram per meter cube. So 2500 is the answer. Now the next one, calculate the percentage uncertainty in the density. How do we calculate the percentage uncertainty? We look at the equation that we use to calculate the density. So the equation that is being used to calculate density is mass per volume. This is division. If it is about division, you have to add the fractional uncertainty. So once you have added out all the fractional uncertainty, you can just multiply by 100 to get your percentage uncertainty. So I'm going to find percentage uncertainty of density. It is related to mass and volume. So I find the fractional uncertainty of my mass first, plus the fractional uncertainty of volume, capital V, and you multiply by 100%. Right, seems easy. Now I break it down. I break down my volume into X, Y, and Z. So I put delta X because the volume depends. Volume is equal to X times Y times Z. Right, so this is multiplication. So to find the percentage uncertainty, you have to add up the fractional uncertainty first before you multiply by 100. So delta X over X plus delta Y over Y plus delta Z over Z, and everything else you multiply by 100%. Mass. Okay, the good news about the fractional uncertainty is that, do you still remember that fractional uncertainty has no unit? Therefore, you can just take any values here. It doesn't matter whether you convert from kilogram to gram, from cm to meter, it doesn't matter because there's no unit for fractional uncertainty. Okay, so I'm going to take the absolute uncertainty of mass 0.001, 0.001 divided by 0.243 plus, remember what I told you, x is in cm, but don't bother because delta x is in cm and x is in cm and cm are cancelled off. So I'm just going to put 0.01 over 5.41. 0.01 over 5.41 plus delta y 0.01 over 11.09. 0.01 over 11.09 plus delta z 0.01 over 1.62. 0.01 over 1.62 and everything else here I multiplies with 100%. And remember, let your calculator handle. And one more thing about the rule of the percentage uncertainty. Percentage uncertainty can be recorded in 1 to 2 significant figures only. So I'm going to put it in terms of 2 significant figures, which is 1.3%. So 1.3% is the answer. C, the true value of the density of the glass is different from the answer in B part 1 because of the systematic error in the measurements. Suggest one possible cause of this systematic error. So your true value of the density depends on the measurement of mass and the measurement of the volume. Right, so look at the volume. Volumes are measured in cm. So since the value of the x, look at the value of x, 5.41 cm is quite small. Y, 11.09, that's the largest value of the measurement of length. And Z, 1.62 is even smaller. I believe X, Y, Z, right? The apparatus that used to measure X, Y, Z, right? Maybe why we use meter rule, right? But you can also use vernier caliper to measure Y, to measure X, and to measure Z, right? So I would say the easiest one, zero error. Systematic error is related to the system. It is related to the apparatus. So I would say zero error of vernier caliper. Calipers. Done. Now, question number 2A, define linear momentum. Momentum is being defined as the product of mass and velocity. Done. B, a car of mass 1,800 kilogram is moving in a straight line. Fig 2.1 shows the variation with time t of the momentum p of the car. Calculate, first one, calculate the maximum speed reached by the car. Now, since the first part of question number 2, the question asks you to define momentum. This is something related to momentum. Look at momentum. Linear momentum depends on not just mass, but also velocity. Speed in a certain direction, right? So I want you to see this. This is y-axis is momentum, right? So if you want the maximum speed, that means ignore the direction of the velocity, the direction of the speed, right? You don't bother about negative and positive, right? So you look at the peak of the momentum. Peak here. Look at the peak on the y-axis. This is 7.2. Right, this is the value of the maximum momentum. So maximum momentum, I just write it out first. Maximum momentum. The value of the maximum momentum is 7.2, but not just 7.2. You have to be extra careful because there's a power on your y-axis times 10 to the power of 4. Newton second. And still recall how to calculate momentum, right? Momentum is equal to mass multiplies by velocity. Velocity is just related to direction, right? If you want to find the speed, just ignore the direction, which is equal to 7.2 times 10 to the power of 4. Mass is given as 1,800 multiplies by V. I put it as speed, 7.2 times 10 to the power of 4. V is equal to 7.2 times 10 to the power of 4 divided by 1,800. So V maximum, I mean the speed, maximum speed, it has to be small letter of V. V maximum, this is max, right? This is maximum. Now V max is given as 40 meter per second. So the answer is 40 meter per second. Now, since you have the maximum speed, second part, you have to calculate the maximum kinetic energy of the car. So you remember the equation of the kinetic energy. So this is related to maximum kinetic energy, which is equal to half mv maximum square. Right, so the mass of the car is 1,800 and the maximum speed is 40 square. So let your calculator do the work. 1.44 times 10 to the power 6 joule is the answer. 1.44 times 10 to the power 6 joules is the answer. The next one, show that the acceleration of the car at time t equal to 4 seconds is 5 meter per second. Now, at 4 seconds, this is our 4 second right here. I have to look at the value of momentum first. Okay, the question asks us to find this value right here is 3, 3.2, 3.4. This is 3.6. Right. Since this is related to acceleration, okay, I want you to recall something, right? From Newton's second law, do you still remember resultant force is equal to ma? And resultant force is being defined as the rate of change of momentum. So the change of momentum, right, at 4 seconds, from 0 second to 4 second, this is a straight line. So the change of momentum must be constant, which is 3.6. 3.6 minus 0 over the time. The time is 4 seconds. 3.6 times 10 to the power 4, sorry. This is times 10 to the power 4 divided by 4 is equal to 1,808. Now, A is equal to 3.6 times 10 to the power of 4 divided by 4 and divided by 1,800. So your answer is exactly 5.0 meter per second square. Now I write this cap nicely. Now the next one, determine the distance traveled by the car between times t equal to 0 and t equal to 12 seconds. Now, I look at when the graph is being given, just bear this in mind. You can either find the gradient of the graph, which is equal to the resultant force, or area under the graph. Now, this is a momentum against time graph. The area under the momentum against time graph, okay, area represents momentum multiplies by time. Okay, then you put in the equation of momentum, mv, times time. Could you see that this is what we call speed times time? Okay, speed multiplies by time is called distance. See that? Now, all I need to do is just to find the area under the graph first, and then I have to divide by m in order to get my distance. Now, the area under the graph, I am going to split it up to two triangles. So this is the first triangle. I'm just going to use red color. So the first triangle plus second triangle. So area is equal to, I've just put area 1, half multiplies by 7.2 times 10 to the power 4 times 10 to the power 4 multiplies by 8. Then you get an answer right here. 8 times 7.2 times 10 to the power 4 multiplies by half. I get 2.88 times 10 to the power of 5. Right, this is Newton second, okay? Newton second multiplies by second. So Newton second square. And then the area, Okay, area 2, another triangle, half times 12 minus 8, that is 4. This is 4. Times 7.2 times 10 to the power of 4 times 4. So 7.2 times 10 to the power of 4 times 4 multiplies by half. And I got 1.44 times 10 to the power of 5, right? So the area would be 2.88 times 10 to the power of 5 plus 1.44 times 10 to the power of 5 equals, mass is 1,800, multiplies by distance. So you just make distance as the subject. Distance is equal to 2.88 times 10 to the power of 5 and divided by 1,800, you get exactly 240 meter. So 240 meter, that's our distance. C, on Fig 2.2, sketch the variation with time t of the acceleration a of the car in B from t equal to 0 to t equal to 12 seconds. Now, in order for me to sketch the acceleration, right, I have to know one more thing. From Newton's second law, rate of change of momentum or the resultant force is equal to ma. Right? Delta change in momentum over delta t is equal to ma. Rate of change of momentum, you can classify this as gradient, is equal to ma. Could you see that mass is constant? That is why gradient is directly proportional to acceleration. Right, so the acceleration from 0, right, we have got it from 0 to straight line. 8 seconds, 0 to 8 seconds, because it is a straight line graph, therefore the gradient of the graph is constant, right? Remember, we have calculated the value of the acceleration, which is 5 meter per second square, right? So because it is a straight line graph, not just stop at 4 seconds, but stop at 8 seconds. So at 4 seconds, the acceleration is the same as 8 seconds. So I'm going to stop right here, okay, at 8 until 8 seconds. This is 5. So you draw a horizontal line. Okay, done. And then start from 8 seconds onwards to 12 seconds. Right, you have to find another gradient right here. So I'm going to find it right here, gradient. This is a negative gradient, so your acceleration would be negative. Right, the gradient. Okay, I put gradient. I just write the word gradient. Don't want to confuse you with the mass. So I just put gradient. Okay, the method is exactly the same as what I did here. Is equal to ma, because the gradient of the graph, rate of change of momentum, is equal to resultant force, which is equal to ma. Right, I get 2 points here. This is 8 and 7.2 times 10 to the power of 4. This is 12 and 0. So I take 7.2 times 10 to the power of 4 minus 0 over 8 minus 12, equal to 1,800 times acceleration. So 7.2 times 10 to the power 4 divided by 4. And, okay, 7.2 times 10 to the power 4 divided by negative 4. And then divided by 1,800. So your acceleration is equal to negative 10 meter per second square. Right, so from 8 to 12 seconds, okay, it is constant deceleration. Okay, which is negative 10. Done. Okay, if you have any hesitation, if you're confused with the graph that I drew, do not hesitate, just comment below. Now, we move on to question number 3. A, state what is meant by the work done by a force. You can actually define the work. Work is being defined as product of force and distance. Move in the direction of force. That's it. B, a block of mass m is raised vertically at constant speed. The vertical height gained by the block is delta h, as shown in Fig 3.1. Derive an expression in terms of m and delta h for the change in gravitational potential energy, delta EP of the block. State the meaning of any other symbols that you use. Now, they ask us to use expression, right? Derive expression in terms of, I'm going to use the work first. Work is equal to force times the perpendicular, force times the distance moved in the direction of force, right? So force times distance. Now, this is my work, right? Work is actually converted when you do work, you move or you raise out the block, you are giving the block gravitational potential energy. So your work is transferred to the gravitational potential energy of the block, which is delta EP. F, that means the weight of the block. You have to overcome the weight of the block, which is mg. And the distance moved is delta h. Do you see that? Right. Now you have to explain the other symbols that you are using, okay, where G is gravitational acceleration. Done. C, an electric motor has an input power of 900 watt. The motor takes 1 minute to leave a load of weight 240 Newton at constant speed through a vertical height of 150 meter. Resistive forces are negligible. First part, show that the work done by the motor on the load in 1 minute is 36 kilojoule. Right, so I am going to show the work, okay, is equal to the change in gravitational potential energy of the load, which is mg delta h. Right, since the weight is being given, do you still remember the definition of weight? Weight is being defined as mass times gravitational acceleration. So I'm going to replace it with 240. Right, delta h is the height, which is 150. So you will get exactly 36,000 joules. All you need to do is just to convert to kilojoules divided by 1,000. Now the next one, determine the useful output power of the model. Okay, useful output power, output, right, is equal to useful output energy, useful output energy divided by time taken. Power is equal to, power is being defined as energy per unit time, right? So the useful output energy is the one that we have calculated because you leave out the load, which is 36,000 joules. So I'm going to put 36,000. And, okay, the time taken is 1 minute. 1 minute is 60 seconds. Remember to convert to second because the unit of power is watt, right? So you will get 600 watt. 600 watt is the answer. And the third one, use your answer in C part 2 to determine the efficiency of the model. So efficiency, since this is related to power, so I am going to use output power, useful output power over input power multiplies by 100. Useful output power is 600, the one that you have calculated above, and the input power, remember, an electric motor has an input power of 900 watt. So just replace with 900 and you times 100%. And my answer is 67%. 67% is the answer. The next one, some of the power wasted in the motor is dissipated by the resistance of its coil. This dissipated power is 280 watt. The coil of the motor is made from wire of total length 23 meter. The wire has a cross-sectional area of 2.6 times 10 to the power negative 8 meters square, and it is made of metal of resistivity 1.7 times 10 to the power negative 8 ohm meter. Calculate the current in the coil, right? So since the power dissipated is already been given, so I recall the equation of the power, which can be related to electricity. I have different power here. I have P equal to IV. I have P P equal to V square over R, and I also have P equal to I square R. But at the end of the time, I am going to choose the third one. Why do I choose P equal to I square times R? Because the question did not provided me with V. So I don't waste my time. Yeah? So I use I square R. Power dissipated is 280. Now I square R is the problematic one, right? But don't worry, still remember, resistance is equal to rho L over A. Resistivity times length divided by cross-sectional area. So you find your resistance first. 1.7 times 10 to the power negative 8, length is 23, and divided by cross-sectional area, which is 2.6 times 10 to the power negative 8. So I'm going to do that right now. 1.7 times 10 to the power negative 8 multiplies by 23 divided by 2.6 times 10 to the power negative 8. And you should be able to get 15.04 ohm. It doesn't matter. I put it in terms of 4 significant figures. I'm aware of that, but this is not my final answer, so it doesn't matter. I will sub into the equation. This is 15.04. Make I square as the subject. So I is equal to 280 divided by 15.04, and you square root the answer. You should be able to get the value of I, which is 4.31 ampere. I put it in terms of 3 significant figures, and you could choose it to put it in terms of 2 significant figures. Not a problem. The next one, question number 4. A, define the Young modulus of a material. Young modulus is being defined as the ratio of stress to strain, or stress divided by strain. Not a problem. B, a metal wire P that obeys Hooke's law is stretched within its limit of proportionality. On first one, on Fig 4.1, sketch the variation of tensile force in a wire with its extension, right? Do you still remember Hooke's law? Hooke's law states that, okay, since it is stretched within the limit of proportionality, so I am going to draw the graph, but you have to start from origin because force is directly proportional to extension. Okay, so this is the graph that you are supposed to draw. You start from origin. Okay? Now, second part, state the name of the quantity represented by the gradient of the line in Fig 4.1. The gradient of force against extension graph is called spring constant. And the third one, state the name of the quantity represented by the area under the line in Fig 4.1. The area of the force against extension graph is called elastic potential energy. C, another wire piece made from a metal that has twice the Young modulus of a metal P. In B, wire Q. Okay, I'm going to write here, this is P and this is Q. How about that? P, this is a Young modulus of P, and then Young modulus of Q is equal to twice. Let me see. Twice Young modulus of P. Okay. And wire Q has the same volume as wire P, so volume is the same, V and V, but has double the cross-sectional area. Area of P, so area of Q is double area of P. Done. Two wires are suspended by equal tensile forces within the limits of proportionality. State and explain how the extension of wire Q compares with the extension of wire P. Now, I would write down an equation for P first. Is that okay? Now, Young modulus of P. Young modulus is equal to stress over strain. Stress is equal to force over cross-sectional area divided by strain is equal to extension over original length. So you will get FL over AX for Young modulus. The problem is that, okay, we don't know what happens to the length because the question did not mention whether the length of P is longer or the length of Q is longer. So I'm going to replace the length. Yeah, volume is being given, right? The question did mention that the volume is the same. Now I'm going to do it here. Volume is equal to cross-sectional area multiplied by length. Therefore, length is equal to volume over area. Sub into this equation. Young modulus of P is equal to force times volume over area, right? Area times this area, you will get area square multiplies by extension, right? That is extension of P. Done. What about Q? Okay, for Q, Young modulus of Q. I'm going to use the same one, the force, right? These two wires are extended by the same force, so I'm just going to put it as F, right? Volume, they have the same volume, so I'm just going to put it V. And this is area, oh wait, this is area of P, sorry, yeah? This is area of P, so this is area of Q square multiplies by the extension of Q. Done. Now, this is my first equation, but I want to find what happens to the extension of wire Q. So I need to sub in certain stuff here. So now we see that the Young modulus of Q is 2 times the Young modulus of P. So I'm going to replace that. 2 times the Young modulus of P, force times volume. And the cross-sectional area of wire Q is 2 times the cross-sectional area of wire P. So I just put 2 area of P, but I have to square the whole thing, remember? Times extension of Q. Now I modify, make it simpler. F volume over 4 times the area of P square extension of Q. Second equation, right? Now I am going to modify these two simultaneous equations. I'm going to solve it. Is second equation divided by the first equation. So second equation, I have 2 times the Young modulus of P divided by Young modulus of P equals, I better write it nicely. Sorry. Here drawing. Okay, here equals FV over 4 area of P square extension of Q multiply straight away invert it. So area of P square extension of P over FV. Now, is this my favorite part? So I cancel Young modulus of P, FV, FV, AP square, AP square. So I left 2 is equal to extension of P over 4 times extension of Q. Therefore, 8 times extension of Q is equal to extension of P. Now, extension of Q is equal to 1 over 8 extension of P. That's the answer. Now, extension, state and explain. Right, okay, all these equation, if you want to write it down, feel free to do so. Extension of wire Q is equal to 1 over 8 extension of wire P, right? Because why? Okay, first of all, right, because extension, right? Extension, you can just write it. Extension is directly proportional to length. And extension, okay, extension also inversely proportional to Young modulus. Young, okay. Or you want to show all the calculation here, you feel free to do so. Young modulus. And actually, if you do it, right, the length of Q is equal to half the length of P. Length of Q is equal to half length of P. Yeah, show from the equation. And we are done with that. Question number 5A, potassium 40K 19 undergoes beta negative decay to form a nuclide of element X. Particle Z is emitted during the decay. The equation for the decay is shown. First part, state the values of P, Q, R, and S. P, you remember, nucleon number. So you modify the nucleon number. You know R and S here because this is beta negative. Beta negative represents fast-moving electron. R is 0, S is -1. And then after that, all you need to do is just to balance. Nucleon number on the left-hand side is balanced by the nucleon number on the right-hand side. So P is 40. On the proton number on the left-hand side must be balanced by the proton number on the right-hand side. Since the left-hand side is 19, Q plus -1. So Q is 20. Now state the name of particle Z. This is about beta negative decay, right? Particle Z is called anti-neutrino. And the third one, state the name of the class of fundamental particle to which both the beta negative particle and beta Z belong. Antineutrino and beta electron, right? They are belong, okay, to group leptons. And determine the quark composition of an alpha particle. Quark composition related to proton and neutron. So this is alpha. It is helium nucleus. It consists of 2 protons and 2 neutrons. Proton, okay, 2 times. Protons are made of up, up, down quarks. Neutrons are made of up, down, down quarks. So you multiply, you have 2 up, 2 plus 2 up. You can add it. Okay, so you have, okay, 2 up plus 2 up plus 2 down plus, straight away plus with a neutron, 2 up plus 2 down plus 2 down. So you end up 1, 2, 4, 6. So 6 up and 6 down quarks. Quark composition will be, okay, 6 up quarks, okay, 6 down quarks. Now, question number 6. 2 coherent sources X and Y of microwaves of frequency 2.5 times 10 to the power of 10 hertz are a distance of 0.18 meter apart in a vacuum, as shown in fig 6.1. There is a phase difference of 90 degrees between the waves emitted at the 2 sources. A microwave detector moves along the line PQ, which is parallel to the line joining the 2 sources and which is 2.3 meter away from it. Point O is on the line PQ at a position that is equidistant from the 2 sources. Point A is the position on line PQ as well, where the intensity of the microwave is the greatest. A, part 1, explain why the position of the greatest intensity is not at point O. Now, first of all, you have to see this. There is initially a phase difference of 90 degrees between the 2 waves. That means, right, if this is the wave from source X, right, emitted at the same time, okay, this is X, right? Okay, this will be the wave of Y, start from here. Can you see that X start from 0, but Y start from a crest? Could you see that? Due to that, right? At O, right? At point O, we would not get maximum intensity or constructive interference, right? So I'm going to write it down. There is an initial phase difference of 90 degrees between source X and source Y, okay, which causes the 2 waves, okay, arriving constructively at point O. Done. Now, on fig 6.1, draw a cross X to show the position of the point on line PQ where the intensity minimum, that is the closest to point O, occurs. Let this point be, right? So I will see this closest to O, right? We want it to be minimum. Okay, so closest to O, right? The minimum should be here. Okay, this is, okay, give me a while. Okay, should be somewhere here. This is minimum. Now, the next one. B1 show that the wavelength of the microwave is 0.012 meter. Could you see that microwave is one of the electromagnetic waves that travel with the speed of light? So I'm still going to use the wave equation, wave speed V equal to F lambda. Microwave in vacuum travel with the speed of light. Frequency is being given, which is 2.5 times 10 to the power of 10. So this is 2.5 times 10 to the power of 10 and multiplies by lambda. Make lambda as the subject. And you should be able to get the exact answer, 0.012 meter. That's it. Second part, for point A on line PQ, determine the difference in the distances delta X traveled by the microwaves from X and the microwaves from Y. Okay, now since the one that I highlighted here, I'm going to use that phase difference of 90 degrees. So I'm going to write down, do you should remember the equation of the phase difference? Phase difference over 360 degrees is equal to the path difference between two sources, X and Y, divided by wavelength. So the phase difference is given as 90 divided by 360, which is equal to delta X divided by lambda, 0.012 meter. So delta X is equal to 90 multiplies by 0.012 divided by 360 degrees, and you should end up getting 0.0030 meter. 0.0030 meter, two significant figures. And use the formula for the double slit interference of light to calculate the distance between the adjacent intensity maxima on line PQ. So double slit interference, lambda, is equal to AX over D. Right, adjacent intensity maxima, that means the distance between the two constructive fringes, bright and bright fringes or loud and loud fringes, right? We call it as loudness intensity because this is intensity. Fringes is really related to light, right? Lambda is given, which is 0.012. A is also given. A is the distance between the two sources, which is 0.18 meter. So I'm going to put a 0.18 meter times X over D. D is the distance between the two sources to the screen, which is 2.3 meter. Just put here 2.3 meter. Right, X is equal to 0.012 multiplies by 2.3 divided by 0.18. Your X should be equal to 0.15 meter. 0.15 meter is the answer. Now, the next one, question number 7a, fig 7.1 shows two resistors connected in series with a cell of electromotive force, EMF, 1.5 volt, and internal resistance, 0.28 ohm. One of the resistors has resistance of 1 ohm. The other resistor has resistance R. The terminal potential difference, PD, across the cell is 1.36 volt. Show that the current in the circuit is 0.5 ampere. Now, I am going to use the equation of EMF. So I'm going to write here, EMF is equal to terminal PD plus IR. R means internal resistance. EMF is given as 1.5. Terminal PD is given as 1.36. I don't know the value of I, but I have the value of internal resistance, which is 0.28. Now, I would be equal to 1.5 minus 1.36 divided by 0.28. The value of I, you will get exactly 0.50 ampere. And the second part, calculate the combined resistance of the two resistors. Right. So, since I have the value of the current and I have the value of the terminal potential difference, I can use Ohm's law, V equals IR. But the V is not EMF, the V is called terminal PD. Terminal PD, which is 1.36, I is 0.5, and I times R. R is equal to 1.36 divided by 0.5. So the value of R is 2.72. I put it in terms of three significant figures. If you want to put it in terms of two significant figures, that would be 2.7 ohm. And the third one, use your answer in A part 2 to determine the resistance of R. Could you see that R and 1 ohm are connected in series? So total resistance is equal to R plus 1 ohm. Total resistance is 2.72 equal to R plus 1 ohm. R is equal to 2.72 minus 1, which is equal to 1.72 ohm. 1.72 ohm is the answer. The next one, the circuit in fig 7.1 is disconnected and the two resistors are reconnected to the cell, now in parallel with one each other. On fig 7.2, complete the circuit diagram to show this arrangement. Now, all you need to do is just to draw these two resistors, 1 ohm, and this is R. Okay, they are being connected in parallel. And we are done. Now, the next one, explain without any calculation whether the terminal PD across the cell is now lesser than, equal to, or greater than 1.36 volt. I want you to see this, right? We are using this equation of Ohm's law. Since the two resistors are being connected in parallel, the total resistance between these two resistors would decrease. So due to the total decrement in the total resistance, right, there will be more current that is flowing, right, in the whole circuit, right? And then, okay, what happened to the terminal PD across the cell? What happened to the terminal PD? Since the total resistance decreases, right, there will be less work needed to be done to move the charges across the resistance, across the resistor. So that is why the terminal PD would have to decrease, right? So I would say terminal, let me write it nicely, terminal PD decreases. Okay, explanation is that, okay, total resistance of circuit decreases, okay, less work needed to be done to move the charge from one point to another, right? Or you can use Ohm's law to explain, right? Or you can say that the total current increases, total current of the circuit increases, right? That is all about our discussion, right? On October-November 2024, paper 21. Hey, if you want a sample answer, don't worry, okay? Go to my description and just click on the Google Classroom file and the answers, the sample answers are there, right? So thank you very much for watching and I will see you in my next video. Bye.